Test 1, question 14. In the figure above, segment BC is 4 units long, segment CD is 8 units long, and segment DE is 6 units long. What is the length of segment AC? Alright, so for this problem, we're given the following graph connecting points A, B, C, D, and E. There are a couple of important things we need to note before we get into the numbers. Firstly, I want to note that the lines created by a segment BD and the line created by AE are two separate lines that are independent of point C. Point C is simply the intersection of those two lines. Second, I want to note that we have two right angles connected to the same sets of two lines. And this tells us that these two shapes must be similar triangles. Similar triangles are important because their side lengths can be determined through a ratio. Now that we know this basic information, what I want to do is I want to write each of the lengths next to each side. So side BC is 4, DE is 6, CD is 8, and we're trying to find length AC. First, since these are similar triangles and their side lengths must be related by some ratio, we want to consider the sides that have similar lengths. So we can say for AC it's similar to CE because they are on the same line. We can also say that BC is similar to CD because they're on the same line. And then finally, DE and AB are similar because they have the same placement within the same triangle. If we were to rotate this triangle, what you would get would just be a big triangle with a little triangle inside of it. So these are similar. So here we can see that similar lengths BC and CD are given as the ratio BC over CD is equal to 4 over 8, which is the same as 1 over 2. Now that we know the ratio, we can take the fact that this is the sides DE and AB are similar to find that AB is going to be equal to this ratio, 1/2 times the length of DE, which in this case is 1/2 times 6, which is 3. So that gives us that side AB is length 3. Next, we want to make use of a formula known as the Pythagorean theorem. The Pythagorean theorem is an equation that allows us to determine the slanted side of a right triangle known as the hypotenuse. And a right triangle, of course, is simply a triangle with a right angle or 90-degree angle in it. The Pythagorean theorem is given as a squared plus b squared equal to c squared, where a and b are simply the lengths of the right triangle connected to the right angle. So in that case, that would be AB and BC. Okay? So we can write AB squared plus BC squared is equal to AC squared. Now we want to solve for AC, so what we'll do is we'll take the square root of the left side of the right side so that we get AC, but we need to do the same thing on the left side, and if we rearrange this, flip it so that AC is on the left side, the square root and the square cancel, we're left with AC is equal to the square root of AB squared plus BC squared. If we just plug our numbers in for AB, which is 3, so 3 squared plus 4 squared, all under the root. If we look at 3 squared, that's 3 times 3, which is 9. And then 4 squared is 16. And if we add 9 and 16 together, that is the square root of 25, which we know to be 5. And that is answer choice A. Thank you for watching this video. These math tutorials are based on the TSI Assessments Secrets study guide by Mometrix. You can find the 2016 version here or the 2020 version, which was updated based on the TSI 2.0 exam. If you would like to reach out to the instructor, you can reach out at the email on screen, or if you have general questions for Del Mar College Veterans Upward Bound, you can reach out at vub@delmar.edu or text or call the number on the screen. Finally, don't forget to like and subscribe for more content like this.